Hello everyone. Now we have to discuss last type of parameters. Those are transmission parameters. The other name of this transmission parameters is nothing but ABCD parameters. Simply these are T parameters. T represents what? Transmission. So transmission means what? We are using this type of parameters in power system engineering, that is power transmission engineering. So in the transmission what we have? So source side to receiving side. Okay, source means what? It has to supply. Receiving means what? Is it has to take in. Okay, so you can write that point here. ABCD parameters are widely used in analysis of power transmission system. That's why these parameters are called as transmission parameters. Okay, that is what is the model? So this is the input port, right? This is the supply voltage, right? P1. This is what D2. Here we can represent the current direction, reverse direction of that current, because entering is like this. Okay, that is, you can write this is, or you can write sending end. Instead of writing source side, sending end. Sending end. This is what? Receiving end. So we can transmit the power from sending end to receiving end. So for that we can use this transmission parameters. That's why the current direction is what? We have to transmit the power from sending to receiving. That's why we can represent the current direction in opposite direction of that 2-port terminal, right? That's why we can take current direction as negative. We can considering output port current as negative value. Why it is negative value? Because direction changes. Okay, then what is the representation of ABCD parameters in this? P1 I1. Okay, input voltage and input current we are representing with sending end side. Sending end voltage is V1, sending end current is I1. Okay, A, B, C, D. Now we have what? Receiving end voltage, receiving end current. So from this we can write V1 which is equals to AB2, sorry here minus, right? Minus BI2, like that. P2 which is equals to CB2 minus DI2. So from this what you have observed, sorry, this is I1, right? So from this, what you have observed? Voltage, receiving end voltage, receiving end current. So to get the values of A, B, C, D, first we have to short circuit receiving end voltage, then we will get B and D. To get A and C, we have to open circuit output port, then we have to get A and C. That's it. Okay. First, assuming the receiving end to be open circuited. To be open circuited, that is I2 should be equals to 0, right? If I2 is equals to 0, what we have? Sending end voltage, which is equals to A into receiving end voltage, like that. Sending end current, which is equals to C into receiving end voltage, right? From this, you can get A is equals to V1 by V2. V1 by V2 is nothing but what? Reverse voltage ratio. C is equals to what? I1 by V2. I by voltage is nothing but what? Transfer admittance, right? This is what? Reverse voltage ratio. This is what? Transfer admittance. What are the units? Reverse voltage ratio, therefore unit test, because gain, right? Reverse voltage gain, you can call it as reverse voltage gain. This is what? Admittance most. That's it. Next, assuming the reverse receiving end to be short circuited, that is V2 is equal to 0. If V2 is equal to 0, what we have? V1, which is equals to minus C I2 I1, which is equals to minus D I2, right? So from this we can get another relations are what? C is equals to what? Minus V1 by I2, like that. Fourth one, D is equals to what? Minus I1 by I2. Those are called as what? C is what? Sorry, C and A, B, that is B. This is B, right? Then B is called minus V1 by I2. V1 by I2 is nothing but what? Transfer impedance, right? Transfer impedance. What about this I1 by I2? I1 by I2 is nothing but what? Reverse current ratio. Reverse current ratio. Units are for transfer impedance ohms, this is unit plus, that's it. This is all for transmission parameters. We have A, B, C, D. Okay, here we can write node point. What is that node point? There is no equivalent circuit exists for the equations of transmission parameters. So there is no equivalent circuit for this transmission parameters. So what we have discussed, so ABCD parameters are widely used in analysis of power transmission. That's why the other name of this parameters is nothing but transmission parameters. That's why we have sending end, we can say that sending end and receiving end. So from that we are having the equation with respect to what receiving end, that is receiving end quantities are receiving end quantities are independent, right? Sending end quantities are dependent, right? From this, first we have to short circuit receiving end voltage, like that open circuit receiving end current. From that we can get the relations. Okay, this is about transmission parameters.